Good morning, students. In last session, we are seeing the examples and how to use RSA in digital signature. Now, we are continue with upcoming outline session is Diffie-Hellman Key Exchange, in which we are seeing the parameter creation, in which a trusted party choose and published a large prime P and integer G having a large prime order in Fp. Here we are applying a private computations. Alice and Bob both are. Alice is choose a secret key integer A and Bob is a secret integer B. Here how to exchange a value. Alice send A to Bob. Now Bob get A is a secret message in form of encryption. That means Bob get a cipher text, and this is all about key exchange. How to exchange a key using a RSA. Here we are learn DH key exchange, Diffie-Hellman key exchange. Now when Bob get a cipher text by using DH key exchange equations, the Bob sends a B to Alice once again by key exchange. Now further private computations are Alice does compute the number b raised to a under bracket mod p. Then from Bob's side compute the number a raised to b mod p. The shared secret value is b raised to a is equal to under bracket g raised to b bracket close raised to a. Now the equation is a raised to b under bracket mod p. This is a Diffie-Hellman key exchange. You need to remember the equations for applying key exchange. Now let us see how algorithm works. The first step is for Alice and Bob to agree on a large prime P and A non-zero integer G modulo P. Both are prime. The next step is for Alice to pick a secret integer A that she does not reveal to anyone. That means it is a private and authenticate person only access the kind of key for encryption, or when he or she get applying a cryptographic algorithm on particular plain text. She does not reveal to anyone, while at the same time from receiver end Bob pick an integer b that he keeps a secret. Bob and Alice, that means sender and receiver, the receiver and sender use their secret integer to compute. We apply this equation. A is equal to g raised to a under bracket mod p, and b is equal to g raised to b under bracket mod p. The next exchange these computed values. Alice send A to Bob, and Bob is a receiver, sends B to Alice. Note that Dart gets to see the value of A and B since they are sent over. Finally, Bob and Alice again use their secret integers to compute. A is equal to BA mod P under bracket close, then B is equal to a raised to b under bracket mod p. The value that they compute a0 and b0 respectively are actually the same, since a is equal to b raised to a is equal to g raised to b bracket close a. At last we get the value of a raised to b is equal to b dash under bracket mod p. This is all about how this algorithm works on basis of equations. It is used for secret integer to compute and respectively actually we get the same values. Once again, algorithm are here. We seen the steps in the algorithm. Sender and receiver Alice and Bob agree on a prime number base G, is choose a secret number A and sends to Bob. Once again, a secret number is chosen by Bob is a B and sent to Alice. Alice compute and then Bob computes. Using a mode equation, both sender and receiver can use this number as their key. Notice that P and G need not be protected. Here we use this word P and G need not be protected because both are prime number based G. For example, sender and receiver agree on P value P and G. Here we taken P is equal to 23 and G is equal to 5. The Alice choose A is equal to 6. Sends 5 raised to 6 more, 23 is equal to, we get 8. Same for B, the value of B is equal to 15. Sends once again 5 raised to 50 more 23 is equal to 19. Then Alice compute 90 raised to 6 more 23 is equal to 2. And Bob is a receiver, is compute the value 8 raised to 15 more 23 is equal to 2. Then 2 is the shared secret key. This is all about HL key exchange algorithm, and this is a second example we are learned here. Clearly, much larger value of A, B and P are required. And eavesdropping cannot discover eavesdropping. We already learned in unit number 1 when we start introduction. Cannot discover this value even she knows P and G and can obtain each of the messages. Then DH key exchange is solve the following dilemma. Both parties want to share a secret key for use in a asymmetric cipher, but their only means of communication is insecure. Every piece of information that they exchange is observed by their adversary. That means authenticate parties is a dark. How is it possible for Alice and Bob, sender and receiver, to share a key without making it available to Dart? This is a question. At first glance, it appears that Alice and Bob face an impossible task. It was a brilliant solution of this dilemma inside of Diffie-Hellman Key Exchange. This is another example we seen in previous section. Thank you. Jai Swaminarayan.